Okay, now that we have the energy into the atmosphere from the sun, we're going to have to do something with that energy. What we're doing with it is causing temperature changes. The temperature is not uniform, as you well know, across the world. And that is the reason why there's air motion across the globe in the atmospheric circulation. That's why we have weather. So, with that, what are some of the causes and consequences of heat transfer within the Earth's atmospheric system? So, all matter is composed of molecules, and these molecules vibrate. There's continual motion in them. The faster they vibrate, the more energy those molecules have. And temperature is directly related to that kinetic energy in the molecule as it's vibrating. So, think about it. The hotter the temperature, the more the molecule is vibrating. The lower the temperature, the less the molecule is vibrating. So we're dealing with a gas here. So if you have a gas, it means the faster these molecules vibrate, they're pushing the other molecules away. So it actually has a direct impact on the weight of the atmosphere as well. So temperature is directly related to this. And heat is just energy in transfer. In other words, if you put your hand down on a red hot stove, you're going to get burned. And the reason you're getting burned is heat's transmitted from that stove to your hand. So we're going to talk about some of that today. We're going to talk about there's temperature gradients. These are basically changes in temperature over distance. Recently in Beckley, you had a cold front go through, and it dropped the temperature like crazy. So let's just take a quick peek at that here. And this is Beckley. Overnight, right here, the temperature was 56, 55, 45, and then 40 within a matter of minutes. So that is a strong temperature gradient coming across Beckley right there. The wind shifted at the same time. They went to the northwest. You can actually see the temperature fell with time all the way down to 32 degrees within literally about the 2 to 3 hour time frame. So it went from almost mid-50s down to 32. So 20-some degree temperature drop. So you can see the wind shifted at that when that came across. That was your cold front. So there was northwest winds then pulling across a very strong temperature gradient. If you actually looked at the map, you can see here, right now it's 31 degrees. There's 40, but here it's 67. Here's 72 by Richmond. So there is a strong temperature gradient along this front as it's moving through. And these temperature gradients dictate what's going to happen a lot as far as the temperature changes across the United States. So let's bring this back up here. We'll continue on. Now that we've talked about that, heat flows in response to this temperature gradient. So heat always flows towards lower temperature. It tries to eliminate the gradient. So that means that heat is always, even though it's getting colder, the heat that was out ahead of that is flowing back to try to warm where that cold air is coming from. So the cold air is actually dominating them. There are 4 different ways heat can move in the atmosphere: through radiation, through conduction, through convection, and through latent heat, which is basically the change of phase of water. So radiation, we've talked about it in detail. And if you were to look at the satellite today across the U.S., you would see a large area of snow across the mid part of the United States up to West Virginia. And that, think about it, we've learned that the snow has a very high albedo, so it's reflecting a lot of the radiation from the sun. That's why it's staying colder up to the west, because of all that radiation being reflected. When the radiation can come in, even now, if you were driving an enclosed car with your windows up and had bright sunshine coming in on one of the sides of the car, that person is going to feel the warmth of the sun warming the car up. Conduction is another way. It moves between surfaces, and one of the things about it is that say you were out over asphalt on the road, that asphalt gets very hot because it's black, gets a lot of heat into it, and the conduction from that asphalt into the air is fairly strong. So the lower layer of the air is being heated by that asphalt. That's why a lot of times in the summertime you have a little bit higher temperatures over roadways than you actually do in the fields. Convection is another one. Convection is heat being transferred up. In other words, warm air is heated. It becomes warmer than the surrounding air. Warmth rises. It cools when it reaches a certain altitude. It begins to cool. Then it comes back down as cool air, trying to replace the warm air at the bottom. So this is just a process whereby heat is being lifted upwards, cooled, because the atmosphere is cooling as you go higher in it, and then comes back down to be warmed again. And latent heat, so think about molecules. If they're all really vibrating very fast, what happened when they slowed down to a liquid? They had to slow down because first it got colder, so they lost heat into the environment. Heat is released. And then when it went from a liquid to a solid, even more heat's released. Now, if you go the other way, if you go from a solid to a liquid when you're melting, you must absorb heat because you're bringing it in. So these processes provide a change of heat within the atmosphere. It's just all due to latent heating, the moisture. So because the water takes a lot of temperatures to make it change, maritime climates actually do not change a whole lot from winter to summer temperatures. If you look at San Francisco, for example, you see here temperatures are in the 50s in the wintertime, in the low to mid 60s in the summertime. Now, if you did the same thing at St. Louis or even if at Beckley, you would see the curves go down from well down into the 30s, low 30s maybe, all the way up to 80 in the summertime. So that the temperatures change dramatically where there's away from water. But water absorbs, it takes a tremendous amount of heat to heat the water up. It keeps absorbing the radiation coming in from the sun, maybe the warm air coming off of land to gradually heat the water, but it's going to be a very slow process. That's why it takes well into June to July for water temperatures to maybe reach their maximum, probably not until August, which is several months after the maximum sunshine occurred. So this is something about water that holds its heat in the wintertime too, because even now off the North Carolina, Virginia coast, water temperatures are in the mid to upper 40s. So even though it's been fairly cold, temperatures in the 30s and 20s, the ocean is still significantly warmer. And here is just a diagram showing all the radiation and how it comes in and changes. Some of it, as we learned, was absorbed, some of it scattered, some of it goes into greenhouse gases, clouds. It's very complex, how the radiation and the heat balances work in the atmosphere. And there is sensible heating. Sensible heating is in the form of convection, and it can combine with latent heat to cause clouds. Sensible heating is just a change in temperature due to conduction and convection. And here you can see during the day how the sun over the equator, there's a surplus of solar radiation. Even though the temperatures are up, they're not as high as they should be. What happens to that air, that heat? It's transferred to the north where there's a deficit, and it's transferred to the south where there's a deficit. That's why we have air masses moving back and forth across our area, and storms and ocean currents transferring it. An air mass is just a big volume of air. It covers thousands of miles. And if we were to look up in Canada right now, I would bet you would see a large air mass of temperatures generally in the teens to below zero, very dry. Now, if you look down in the southeast, off of maybe the Florida coast, you may find temperatures all in the 70s, low 80s, and very humid air mass. They're related to high pressure in the sense that highs don't have a lot of motion of air, so the ground has the time to change the properties of that air mass to all one property. So when it's in Canada, the air is very cold because the ground's cold and very dry. If it's out over the middle of the tropical Atlantic, the ground is very moist. Obviously, it's an ocean and fairly warm, so it becomes humid and warm air mass. So this imbalance is what causes the weather. And here you can see during the daytime, there's a surplus of radiation that actually goes up until about 2 or 3 o'clock in the afternoon. A few weeks ago, we asked, why does the maximum air temperature occur in the late afternoon? Well, here's why. Heating still takes place. And eventually, however, though, you'll notice in the afternoon, the deficit, the outgoing radiation is more than the incoming radiation. And at that point, temperatures begin to drop. It usually occurs a little before sunset. And because the temperature is the warmest, and we know with black body, the warmer it is, the more radiation it's emitting, so that temperatures actually cool the quickest the first part of the evening, and then as they get colder, they don't cool quite as fast because there's not as much radiation leaving. And so if you have a very bare ground, don't have much moisture around, if you have a drought, for example, temperatures are going to heat up more. Whereas if it's a lot of moisture around and humid, temperatures aren't going to heat as fast because the moisture is going to evaporate and move into the air, and that is going to use up some of the solar energy. We talked about all the snow cover that's out there right now. And here's just an urban map, and you can see how cities actually change temperatures across an area. The more population, the more buildings, they can actually change what the temperatures are around an area. And that can influence the weather in that area as well. So I hope you got something out of this. Let me know if you have any questions.